All right, now I'm on page 420 in the Go Math textbook. Follow along. So we have another example, another problem. A stained glass designer is reducing the dimensions of an earlier design. The dimensions of the triangle shown will be multiplied by 1/2 or 1/4. So this was the original design, but he's going to make this half as big or even 1/4 as big. How will the area of the design be affected? Use a graphic organizer to help you solve the problem. Okay, what do I need to find? I need to find how the area will be affected. By reducing the dimensions. Whoops. Okay. That's what I need to find. What information do I need to use? I need to use the dimensions of the original. The original design and how much it will be reduced by. Okay, which is the 1/2 and 1/4. How will I use the information? I can draw a sketch. Of each triangle. Calculate the area and look for a pattern. Okay, so the original design, height of 6, base of 16, so 1/2 times 16 times 6, and my sketch would look like this, just like the 6 and 16. Okay, half of 16, if I do this multiplication first, half of 16 is 8. So this becomes 8. 8 times 6 then is 48. So the original stained glass triangle was 48 centimeters squared. He wants to make that half as big. So in the next design, he uses half of 6 for the height, which is 3, and half of 16 for the base, which is 8. So he multiplied by 1/2, or you can say divided by 2. So what would the area be of this figure? Well, the area is 1/2 times the base times the height. Oh, whoops, I was using the old height. Okay, well, if I do this multiplication first, half of 8, I know that is 4, and then 4 times 3 is 12. So we notice it started as 48 centimeters, and then it went down to 12 centimeters squared. So it got 4 times smaller, or it was divided by 4. Or we could say, just like on the last one, to get the area, it was 1/4 of the area of the original, which 1/2 times itself gives you 1/4. So 12 centimeters is 1/4 of 48 centimeters. Okay, so I'm going to do something here. Our next multiplier, because he wanted to check 1/4 and 1/2. So 1/4, and if we follow the same pattern where we multiply it by itself, and we get 1/16, that would mean we would have to take the original area, 48, divide it by 16 to see what the new area would be of this even smaller triangle. Okay, let's see what we would get there. Well, 16 times 2 I know is 32, so one more would be 3, and 16 times 3 is 48 exactly. So my area, I'm going to make a prediction here based on the patterns that I've seen from the last page and this page, that my area is going to be 3 centimeters. Because that is 1/16 of 48. And on the last page, if we look back, remember we did 2 times 2. So it was 4, the area was 4 times bigger. When the multiplier was 3, we did 3 times 3. The area was 9 times bigger than the original. So notice we're just multiplying it by itself. Whatever the multiplier was, we multiply it by itself to find the new area. So on this page, 1/2 times 1/2 got 1/4. So 1/4 of 48 was 12. And I think we can do the same thing here, since we're looking for 1/4. If we do 1/4 times 1/4, we get 1/16, and 1/16 of 48 is 3. Let's see if I'm right. Okay, so my new triangle, if it was 1/4 the size of the original triangle, the height would be 1/4 of 6, which would be 1.5 or 1.5 centimeters. And the base would be 1/4 of 16, which would be 4 centimeters. So we do the area formula. Area equals 1/2 times the base, which is 4, times the height, which is 1.5. Well, I know half of 4 is 2, so I just need to do 2 now, because I did half of 4. I already used both of those numbers to get 2, times 1.5. So let's go ahead and do that. 1.5 times 2. Some of you might already see it. I have one number behind the decimal here, no numbers behind the decimal here. So I got to move my decimal over 1. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. Move my decimal over 1, and I get 3.0. And 3.0 is equivalent to 3. So my pattern held up. Okay. So there is our pattern. This is the thing that we're looking for. So when the dimensions are multiplied by 1/2, the area is multiplied by 1/4. And when the dimensions are multiplied by 1/4, the area is multiplied by 1/16. All right. Again, if you have any questions, raise your hand. We're going to continue and go over some more examples.